Welcome to Unit 1, Lesson 1, Part 2. We're going to talk about radian and degree measure. Radian measure could be new for some of you if it's not a review topic. Degree measure should be something you're familiar with from just high school geometry or middle school or even elementary geometry units. We're going to talk about how they're related and how we use them in real life problems. Let's first talk about how we draw an angle in standard position. We draw an angle in standard position by, well, think about how you just draw a regular angle. Usually we would draw an angle that looks like this. Well, the vertex in standard position is always at the origin. Then we always start the angle by drawing one of the rays of the angle on the positive x-axis, always. Then you draw the other side, depending on how many degrees the problem is asking you to do. And this is what we call the terminal side because it's where it ends. Now, what you also have to draw in standard position is you also have to draw a direction. Because if I go in this direction, which is counterclockwise, this is how we're going to plot positive angles. But if I go in this direction, this is how we're going to do negative. So you can really draw an angle in standard position. I can give you several different, an infinite amount of problems actually, where it's going to look like the same angle, and that we're going to talk about what coterminal angles mean shortly. All right, so let's just also think about like the coordinate system here. So if I would draw my angle starting here, and let's say that my terminal side is the same. We've gone 0 degrees. If I draw my terminal side here, we've gone 90 degrees. If I draw my terminal side on the negative x-axis, we've gone 180 degrees in a positive direction. Again, I'm just going in positives. If I go and draw my terminal side on the negative y, we've gone a total of 270 degrees. And again, how am I getting all of this? I keep adding 90 degrees. And then if I go back, I get back to 360 degrees. So I think that probably will make sense. These are a bunch of 90-degree angles. So let's start mapping some angles in a coordinate plane. I'm not going to be the graph police. I want you to try to be as accurate as possible. It is not necessary to use a protractor. So when I want you to draw a 210-degree angle, remember we always start by the positive x-axis. Well, this is 90. This is 180. This is 270. 210 is going to have to fall somewhere over here in the third quadrant. So 210 is a little bit closer to 180 than it is 270. So there's my terminal side, but this is not full credit. I need to put in a direction in order for it to be an angle that I've mapped in standard position. All right, let's talk about negative 45. We always start our angles on the positive x-axis. But since this is a negative angle, I'm not going to go in that direction. Instead, I'm going to go in this direction. Well, if I go in this direction, cut clockwise, this would be your negative 90, your negative 180, your negative 270, all the way back to a negative 360. Well, negative 45 is less than negative 90, and that's going to be right smack dab in the middle. So this would be a negative 45-degree angle in standard position. Okay, 510. Well, think about this. An entire revolution is 360 degrees. So I do have my terminal side, but you're going to have to go one revolution and then some. How do you figure that out? Well, let's subtract 360 from 510. Going old school here. So what I'm really going to graph is a 150-degree angle. So again, this is positive, so I'm going in this direction. So there's 90, there's 180, there's 270. 150 is going to be in between those two numbers. 150 is slightly closer to the 180. But when I draw my direction, you went around 360 degrees, followed by, oh, I didn't want to do that. Let's undo. Followed by another 150. So that's how you denote that you have gone one complete revolution or more. And what we just did in that last example, those angles are called coterminal. Two angles are coterminal if their terminal sides coincide. So that's what's happening here. That's a 510-degree angle. If I wanted to graph a 150-degree angle, it would look like this. The directions is what changes, but the terminal side would be the same. That's why 150 degrees and 510 are coterminal. The numeric relationship between these two measures, they're 360 degrees apart. So if you're being asked to find one positive and one negative angle that is coterminal with the given angle, the easiest way to do this is add 360 and subtract 360. We want one positive, we want one negative. So if I take negative 60 plus 360, I get a 300 degree angle. This means if I would plot 300 degrees, all right, well, this is 270, so it's going to look like this. And then if I would plot a negative 60 degree angle, which would be 60 degrees in this direction, their terminal sides end up at the same place. Now, if I take negative 60 minus 360, what is that going to give me? That's going to give me a negative 420. So it's going to look like this, except you're going to go around one revolution and 60 more. 495. Here is kind of the issue on this one. There could be a multitude of answers. You are welcome to add 360. There's nothing wrong with that strategy. We were going to get, what, 855 degrees if I did my math right. Let's double check that. 0 and 5 is 5. 6 and 9 is 15. Carry the 1, 7, and 8. There we go. You guys, that is a valid answer. But watch what happens when you subtract 360. When I subtract 360, what does that give me? 135 degrees. That is still positive. So this can be an answer. This can be an answer for the one positive that they're asking. In order for me to get to a negative, I'm going to have to subtract yet another 360. And that is going to give me a negative 225 degrees. So my negative coterminal angle is negative 225. Your positive could be either one of those. You could get wild and crazy and keep adding 360 or keep subtracting 360. But on these problems, that's what you do. Add 360 until you get a positive, subtract 360 until you get a negative. All of those angles are coterminal if I would graph all of them. As a reminder, a complement means two angles whose sum is 90. A supplement are two angles whose sum is 180. Since we have a 142 degree angle, we have exceeded 90 degrees, so there is no complement to 142 degrees. On the supplement, if you wanted to, you could do an algebraic equation like I did. You can also do it mentally, and that's going to give us a 38 degree angle. So 38 degrees would be the supplement of 142 degrees. All right, now we're going to switch to radians. And this is what I tell students. Let's say that you were building, I used to have a window in my house that it was a semicircle, and I needed to get blinds. Well, I can't go to Home Depot and tell them that I need a 180 degree window shade, because do I want it to be this big? Do I want it to be this big? They need an actual measurement that I could measure with a ruler. So another way to measure an angle is by the length of its arc. In theory, you would be able to measure the angle with a tape measure. So in calculus, we use radian measure almost exclusively because radian measure is how you can use some type of linear measurement. So here is the definition of a radian. 1 radian is the measure of an angle in standard position whose terminal side intersects an arc of length r. So that means this length of the angle, this length of the angle, and that arc are all of the same. If you just need an estimate right now, it is not exact. So to be clear, this is an estimate. 1 radian measure is near 60 degrees. It's like 58 point something, but this is just a good way to kind of visualize what it is. I also have this link in Schoology, but this is an animation I want to show you. And you're like, I don't see anything. All right, so I'm going to start the animation. All right, so there's a radius. This radius is being used to create the circle. Okay, now I've created a segment that is exactly the same length as that radian. Oh, I went too fast. And so now this is one radian measure. Each of the radii are the same because radii are all congruent in a triangle, and it's intercepting an arc that's the same. So how many times can I do this? All right, that is not quite 180 degrees. If you look closely, it's not a straight line, and I think you'll see why just in a minute. Okay, there's the third or fourth radian, fifth radian. In one circle, you get approximately 6 radians, and then you get this 0.28. Why is that? Think about what the circumference is of a circle, 2 pi r. What if we keep that radius 1? That means that the circumference of this circle is 2 pi. 2 pi is 6.28. There is your 6 radian measures. You've got 6 pieces of the pie, and then that 0.28 is that little piece. So again, I like this graphic. The link is on Schoology so that you can play with it yourself as well and do the animations and kind of figure that out. But I think this is a good representation so you can see if somebody gives you a radian measure, oftentimes it's in terms of pi, in terms of the circumference, but we can also have 5 radians. 5 radians in standard position is going to be an angle that's just past the 270 mark. All right, so here is some algebra to understand the concept of radians. All right, we know that there's 360 degrees in the circumference of a circle if we want to measure in degrees. We also know if we look at the formula for circumference, the formula for circumference is 2 pi r. Let's go ahead. We're going to be talking about the unit circle. Again, the unit circle hopefully is something that you have seen before. In a unit circle, we set the radius to 1. So if I set the radius to 1, that gives me 2 pi times 1. So if I want to talk about degrees, a 360 degree circle is equivalent, when we talk about the unit circle, it is equal to 2 pi radians. So if we were dealing with centimeters, this is approximately 6.28 centimeters, inches, whatever your unit of measurement it is in a length. So let's break this down. All right, if you have 100 degrees in radians, well, if 360 was equal to 2 pi radians, we cut them in half to get 180. So 180 degrees is pi radians. Cut that in half to get 90. So 90 degrees is pi over 2. Cut that in half. And how do you cut it in half? Pi over 2 divided by 2 is the same as multiplying by a reciprocal. So 45 degrees is pi over 4 radians. Now, that works when we can keep having or thirding something. But, you know, if I'm asking you to convert 57.23 degrees into radians, this thought process isn't going to be very efficient. So ultimately, we can do a proportion. And the proportion I'll use is we can do radians is to degrees as pi is to 180. And you guys, you can use 2 pi over 360. That's valid, but I just reduced it because then my numbers are smaller. All right, here we go. Convert 110 degrees to radians. All right, radians over degrees equals pi over 180. 110 is a degree. So radians over 110 is equal to pi over 180. Friends, we're going to keep our answer in terms of pi. We're not going to use 3.14. So let's do cross products. Radians times 180 equals 110 pi. We're going to divide both sides by 180. No, you don't need a calculator. I don't know why I just did all real numbers. Let me replace that. It's just a radian. The zeros cancel. 11 over 18 does not reduce. So 110 degrees is converted to 11 pi over 18 in radian measure. So if you wanted to estimate, again, this is just, I can't stress this enough. I always have a kid in class goes, well, Mrs. Knopf, that's not right. I know, it's an estimate. So 11 times 3 is 33, right? So again, it's about 33/18. 18 times 2 is 36, right? So this is just under 2 radians. So if I was looking at this graphic, again, this is only an estimate. All right, I can't draw on this particular graphic because it's on Chrome on my iPad that I'm recording from. But do you see where it has 1 radian in green? At the end of that radian, that's probably, so you're looking at an angle that's not much more than 90 degrees. That's about what 11 pi over 18 is, just as a rough estimate if you're using estimation skills to kind of have a feel for where is that located. All right, let's convert negative pi over 9 into degrees. So I can use my proportion. Radian over degrees equals pi over 180. This is a radian measure. Please note that I know this is negative. There is nothing special about it. You're just going to keep the negative in your final answer. So I have pi over 9 over degrees is equal to pi over 180. Let's not let that complex fraction, let's just do cross products. Degrees times pi is equal to pi over 9 times 180. Let's do some simplification. D times pi, 9 can go into 18 20 times, so this is 20 pi. Divide both sides by pi. So in degrees, negative pi over 9 is exactly negative 20 degrees. And that should also somewhat make sense here, guys. Remember how I told you you can estimate. I keep saying that. We're going to estimate that pi is approximately 3. I know it's 3.14. If you want to estimate with the 0.14, you can. I'd rather just estimate with 3. So this is approximately 3/9, which is approximately 1/3. And 1/3 of 60 is 20. So again, it's just a way to estimate and to try to get a feel for what this, what a radian measure is. Okay, we're going to finish up this section by drawing the angle in standard position and finding one positive and one negative coterminal angle. I cannot stress this enough. This is not wrong, but some kids don't like the radians. They convert everything in degrees. They do everything in degrees and convert back. That's not efficient. Work with me here on the fractions. We will deal a lot with fractions. We deal primarily only with radian measurements in calculus. So you need to get comfortable. So here we go. I have to graph 7 pi over 4. And if you're like, how on earth would I do that without converting it to degrees? Let me show you two ways. The way that I do this is I think of 7/4 as a mixed fraction. It's 1 3/4 pi. Well, think about this. We said that this is 0. We said 90 degrees is pi over 2. We said that 180 degrees is pi. Well, we can count. So think of this as, this is a half pi, this is a whole pi, so this is 1.5 pies. So sometimes we call this 3 pi over 2. Well, 1 3/4 is more than 1 1/2. So that's where 1 3/4 pi belongs. It belongs in the fourth quadrant. A second way that you can think about this is use that pi is approximately 3. So we're looking at 21/4. So if I think about that, that is 5 1/4 radian. Well, remember our graphic? Again, I can't write on it, but the red is 1 radian, the green is your second radian, the blue is your third, the orange is your fourth, the purple is your fifth. We're at 5 1/4 radians, so we're just a fourth into the yellow piece, which again is in that fourth quadrant. All right, so now that we have graphed this in standard position, now we have to answer, we need to find one positive and one negative coterminal angle. Again, you can convert to degrees and then convert back. But if the answer is, if the problem is in radians, I expect the answer is in radians. That's a lot of work. Well, when we did degrees, didn't we find coterminal angles by adding and subtracting 360? Well, 360 degrees in radians is 2 pi. So we're going to add and subtract 2 pi. So if I take 7 pi over 4 and I add 2 pi, you have to get a common denominator. 2 pi is not easy, or is not hard to convert. It's just 8 pi over 4. So 15 pi over 4 is a coterminal angle to 7 pi over 4. That's positive. Now I need one that's negative. And again, you might not like the fractions, but I guarantee you that is less work than converting 7 pi over 4 into degrees, adding 360, and then converting it back. It's much less work. All right, so now I have 7 pi over 4. Let's subtract 2 pi. Well, you already did the common denominator work. We know it's 8 pi over 4. So 7 pi over 4 minus 8 pi over 4 is negative pi over 4. So that is your angle in, your negative angle that's coterminal. All right, let's talk about 3 pi over 2. Again, think of this as negative 1 and 1/2 pi. So if I'm going in this direction, this is negative pi over 2. This is negative pi. This is negative 1 and 1/2 pi. So my angle in standard position looks like this. On this one, you might not have to actually do a common denominator. You might be able to determine, hey, this way is a 90-degree angle. So a positive coterminal angle to negative 3 pi over 2 is 90 degrees. You can still do the fraction work. Negative 3 pi over 2 plus 2 pi. Well, that is going to be 4 pi over 2. And that gives me pi over 2. So pi over 2 is an angle that is a positive coterminal angle to negative 3 pi over 2. Now, if I want a negative, all I have to do is subtract a 4 pi over 2. So negative 7 pi over 2 would be a coterminal angle that is another negative coterminal angle to negative 3 pi over 2. All right, 7 pi over 8. Again, let's stay in radians. Let's be the radian, think the radian. Oh, well, this is just 7/8 pi. Well, okay, let's think about this. This is 0. This is a half pi. This is a whole pi. Well, if I'm in eighths, 4 pi over 8 would be half pi, correct? So I'm bigger than pi over 2, but 8 pi over 8 would be pi. So my angle in standard position would look something like that. Or if anything, it might even be closer to here. Again, you could always think of this as 21/8. So that's going to give you not quite like 2 and 2 and 5/8 radians. So if you look at 2 and 5/8 radians, your red radian, your green radian is 2. And so you go 5/8 of that blue color. So we would still be in the second quadrant. All right, sorry about that. So now we have to find one positive and one negative coterminal angle. So I'm going to have 7 pi over 8. I'm going to add 2 pi. But I have to be in terms of eighths. Well, in terms of eighths, 2 pi is going to be 16 pi over 8. So a positive coterminal angle would be 23 pi over 8. Then I can subtract 16 pi over 8, which is another way of saying 2 pi. And that is going to give me a negative 9 pi over 8 would be the negative coterminal angle. So enjoy your web assign and have a great day.